Troubleshooting IPSLA, SPAN, and RSPAN. IPSLA definitely wins the Cool Management Protocol Feature of the Year award. What it does is send probes down your different connections, your WAN links, LAN links, whatever, and it simulates different types of network traffic. So you could have it send a probe that looks like a DHCP request or a DNS request or an FTP file transfer or a web file transfer. You could even have it go to a real website and download the website and tell you how it did. So essentially it's a reporting mechanism that says, okay, well, based on the probe type that you configured, let's just say you said I want it to look like voice over IP traffic. I saw this level of service, I saw this delay, I saw this level of packet loss, I saw this much throughput. I mean, essentially it gives you a full report on what that traffic did over your network connections. Isn't that awesome? So a lot of ways you can use that. First off, you could use it for straight up monitoring. I mean, the term IPSLA comes from a carrier agreement, service level agreement, right? When you sign up for a carrier connection, like an internet connection or a site-to-site connection, they're going to say, hey, we guarantee that you're going to be up this amount of time and you're going to have this level of delay and this level. Essentially, they'll scope it all out in a contract. And if they don't meet those levels, then you can take it to them and say, hey, well, I want some money back, or I want to discontinue this service even though we're under a 5-year contract or something because you're not living up to your SLA. So you could use it to, first off, hold the carriers to their agreements and make sure that they are truly delivering on that. You can use it for monitoring as well. If you just want to use it to say, hey, I just want to see, how is voice over IP traffic doing over that, and you can combine it together with another management feature we talked about in a previous nugget, SNMP, to where you can start graphing SLA results over time and so on. SLA can also be used for instance, quality of service. You can have it say, if the quality on this line ever goes below this amount, then I want you to switch over and use that line. You can even tie these things to something called track objects. I know I'm just dumping a lot on you. I'll show this to you in just a second. You can put them on a track object. So I can say, let's just come up with a scenario. You got a router, right? A couple internet connections, but both of them are cable modems, right? Or maybe one's a cable modem, one's a DSL modem, and that they all go out to the internet. Well, the problem with these kind of connections is you can't tell when they go down, because typically the break in service happens somewhere right there, right? But from your router's perspective, the connection is still good. It still shows, fast Ethernet 0/0 is up and up, right? Because the connection between it and the cable modem is just fine. So you have to have some kind of measurement utility that really tells you if that connection is down. Welcome to IPSLA, perfect use of it. What you can do is set up your static routes, and you can say, I want to do, IP route, out this interface, but I want to tie it to a track object, we'll just say 5. And track object 5 could be tied to an SLA probe that every 30 seconds or so sends a probe out to, let's just say, a certain website, Cisco.com, because we know Cisco never goes down, right? And downloads the web page over that connection. And if that download ever fails, then it's going to say, okay, track object 5 is now invalidated, thus the static route goes away until Cisco website downloads can happen through that interface again. Isn't that cool? So, I mean, I'm just giving you a gamut of IPSLA usage, but there's a lot more of them. Let me show you how it's configured. I'm busting out router 1, going to global configuration mode, and I'm going to do IPSLA monitor. And by the way, the syntax, based on what iOS version you're using, sometimes it's IPSLA no monitor, sometimes it has monitor. Just use the question mark to walk yourself through it. So the first thing I'm going to do is define a probe, and you can see I can have 2 billion probes. I'm going to do probe 1. Start there. Hit the enter key, and now it's going to say, okay, what kind of probe is this? This, by the way, is iOS dependent. So as you upgrade to different iOS versions, as you get different feature sets, you'll get different kinds of probes. I mean, there's all kinds of. I mean, I've been on some routers where you hit type ? And there's 3 pages of different probe types. So it's all based on the feature set. So let's just say I want to do a echo, right? Echo. That's ICMP. So it says what kind of protocol you want to use. The only thing you got is ICMP. It says, okay, well, who do you want to ping? I'm going to say, well, let's go with 150.1.1.1, right? You put a different source address if I want to. Hit the enter key. Notice it's now taken me into yet another sub mode. It says, okay, now do you want to tweak this probe in any way? Look at all these options you've got. You've got, how long do you want to keep this history? What is the frequency of the operation? What is the timeout of the operation? What type of service? If you want to put different tags on there that make it look like different kinds of traffic, you can. I mean, there's a whole different slew of options. I'm first off going to adjust the timeout. Let me just say the timeout will be 100 milliseconds. So if I don't hear from a probe within 100 milliseconds, then it's going to be considered down. And I'm going to do a frequency of, let's do once a second, right? Cool. Now, great, I just set up a probe, but it's not doing anything until I schedule it. So I'm going to do IP SLA monitor, and we'll do schedule. We'll say I want to schedule probe number 1. Let's get this guy running. I'm going to have the lifetime to be forever. It's eternal. And then we're going to have a start time of now. Go gadget probe. And so now it's actually going. I can bail out of here and I can do a show IP SLA monitor statistics. Ooh, check it out. 12 successes so far. Return code OK. So, watch this. I can take this and I can combine it into a track object. I can do track object. We'll just say 1. I'm going to tie it to, and by the way, the old name of IPSLA was RTR, Response Time Reporter, and it's funny, Cisco's never updated the two. So RTR equals IPSLA, just so you know. So I'm going to say RTR1, and I'm going to say the reachability. So now I've got this track object 1, right? Let me bail out of here. Do show run include track, and we should see that little track object there. Okay, so now if I ever do a static route, I can do something like this: IP route 00000000, and let's just say my default route was through that 150.1.1.1, but I want to make sure it's pinging and it's responding. If it ever stops responding, I want to remove this static route. Well, that's where I can attach to it track object number 1. Isn't that cool? So now if track object 1 ever goes down because the pings to that IP address ever goes down, this route removes itself from my table. That's cool. Come on. Feature of the year, right? Well, now let's hit SPAN and RSPAN. These features allow you to monitor traffic passing through your switch. A switch by default, with all the collision domains it provides, isolates all the different network traffic types going through your switch. Well, as an admin in troubleshooting mode, you may need to see those different traffic types to help diagnose or solve one of the issues that are going on in your network. So SPAN allows you to see the traffic passing through your local switch, whereas RSPAN, which most people don't know exists, allow you to monitor traffic on a remote switch. That's cool. You don't even have to take your laptop over to the IT room anymore to do these kind of sessions with RSPAN. So the way it works is, let me bring up my switch here. I've got 3750 switch. I'm going to go into global config mode and type in monitor session, and this is just doing normal span. So we'll say monitor session 1. You can have up to 66 span sessions on this switch, which is way overkill. So we're going to say the source interface is going to be, and we'll say fast Ethernet 1/0/1, and I don't know what sports. Hang on, let me do show IP interface brief. Okay, 2/ there we go. That'll be better. So we'll say I want to monitor the traffic coming from fast Ethernet 2/0/1. Now it's going to give me the option. Do you want to see both sent and received traffic? Do you want to see just receive traffic? Do you want to see the traffic that is just transmitted, the sent traffic only? So I'll just say I want to see everything. Everything on that port I want to have as my monitor session. So I'm going to go now and do monitor session 1 and do destination interface, and I can do fast Ethernet. Let's just say I've got my Wireshark laptop plugged into 2/0/10. Okay, that's it. So now I'm monitoring. You can do, by the way, a range of interfaces if you want to see a whole grouping, or some with just send, some with just receive. There's a lot of different options that you can do, but that now will be piping all the interface traffic for fast Ethernet 2/0/1 out interface fast Ethernet 2/0/10. That's SPAN, right? RSPAN allows you to do the same thing, but the way you do the same thing, but do it for remote switches. And the way it does that is by designating a specific VLAN to carry that switch port monitor traffic. Here's how it would work. I'm going to go and create, let's just say VLAN 50, right? This will be my remote span VLAN. This is going to be a VLAN designated to carry monitoring traffic. So let's just say that this switch 2 is sitting in an IDF far, far away, right? I can then go and bail out of this, and let's just say that I've got interface fast Ethernet 2/0/24, which is my uplink to, I'll just put description, uplink to other switch, right? And I'll say switch port mode trunk, switch port trunk encapsulation .1q, switch port mode trunk, switch port trunk allowed VLAN add, and I would add in that VLAN 50, right? So it's going to be sent across that trunk as it goes. Now, what I can do is go exit out of here and do, let's say, monitor session, we'll do 2, and we'll say the source is going to be fast Ethernet, interface fast Ethernet. Let's say I want to monitor 2/0/2 on the switch, but I want to pipe it across the network so I don't actually have to plug in here. So I'll do monitor session 2 destination, but instead of sending it to an interface, I'm going to send it to a destination of remote VLAN 50. Did you get that? So I'm taking whatever comes in and out, and I didn't specify direction, so both. Whatever traffic comes in and out of this 2/0/2, and I'm going to send it to a destination of VLAN 50. Now I went in and added VLAN 50 to my quote-unquote uplink, or where is it? I think port 24, was the uplink that I defined between the switches. So let's just imagine, fly with me. Imagine that I just went, 5 switches down the road to where that VLAN 50 is terminating, and then I would come here. Let's hang on. Host name, other switch. Right? So now, oh, hey, look, I'm on another switch. The one that's receiving that VLAN 50, so, whatever port it's coming in on, I would then do, okay, monitor session, and it doesn't have to match the session number. You can just do session 9 or whatever session you want to use. And we'll say the source is going to be VLAN 50, right? No monitor session 1. Kill that one. Source VLAN 50. I can only go so far, right? Do you see where I'm going with this? And then the next command that would be on there, monitor session 9 destination interface, fast Ethernet, da 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 da. So hang on, it would just look better in a diagram. So we've got, my switch 2 up here where I said I'm monitoring this port right here. This is where my eyes are looking to see that 2/0/2, and I'm going to send it to VLAN, pipe it to VLAN 50, which is assigned to the trunk, so it comes down to however many switches I want. Wherever my monitoring equipment is attached to, that's where I'm going to say, okay, got it. Now I'm going to, actually, here, let's do this. I'm going to say, okay, I'm going to take the source, monitor session, whatever, source VLAN 50, and I'm going to pipe it out, destination, fast Ethernet 1/0/1, right? And then it would come out here to whatever Wireshark device I would have attached. Alright, what can go wrong with these 3 management features? Well, first off, the SLA source and destination address need to be reachable from each end. That's an obvious. The IPSLA, if you're sending probes, they obviously have to be able to get there, right? SLA must be started and the IPSLA responder enabled if needed. Ooh, I'm glad I put that in there. I forgot to mention what that is. So you can actually have IPSLA do exactly what we did, which is probe a specific IP address, right? And I can come back here and do a show IPSLA monitor statistics, and I can see that I've, 959 successes since we had that probe running. That's awesome. Well, the bad thing about doing it that way is if you're measuring for network performance, you can't really tell if it's the network that's causing a problem or the remote endpoint that you're monitoring, right? I mean, think about it. You got a router sitting right here, and you're probing, let's just say, a server. Maybe you're doing a web download, or who knows what you're doing, right? And you're trying to test the network throughput between you and that server. Well, all of a sudden you see, on your graph, this sudden spike up, and you're like, oh man, ooh, and then it goes up again, and you're like, oh, is it? Now you're questioning. You're going, okay, is there a problem with that server, or is there a problem with the network between me and the server? You never know. And that's why Cisco created the SLA responder. What that is allows you to get this server off of there and put another Cisco endpoint with an SLA responder configured. It's a piece of cake to configure, just like IPSLA. You can go into global config mode and do IPSLA monitor responder. And you can just say, okay, the type of protocol I want it to respond to is, and you can have the TCP or UDP or frame relay responder. So essentially, you can have this guy be an endpoint in the test. And what happens is when it receives the probe, so here's your probe, it's going out to the responder. It's like, I'm making it there, Bing, it checks in because this thing is running an SLA responder. It goes, okay, check, I received it at, and it actually measures the response and says, okay, 1.5 milliseconds of time it's been on the road, essentially. And so it goes through, processes, does whatever it needs to do, and then sends that probe back. I mean, that's exactly what the web server would have done, right? But what it does when it sends it back is it subtracts from that probe any processing time that this device encountered on the way. So if this router was bogged down, that's okay. It actually subtracts that from the probe's values, the internal measurements that it's using, so you'll get a nice flat value because it's not taking into account the performance of the router in the equation. That's a cool thing about the IP SLA responder. So anyway, got to start the SLA, right? You can't just configure the probe. You saw that I had to schedule it. And if you are planning to use the SLA responder, you want to go in and enable it. So that's SLA troubleshooting, right? Right here. You can see show IP SLA. Let's run through these real quick. Show IP SLA application. That'll show you all the different probes. Application. Oh, wait a sec. No. See? Different iOS versions. Some of them have the monitor, some of them don't. There we go. This will show you all the different probes that this router platform supports, which is kind of cool. You can see the number of entries we have configured and all that. You can do show IP SLA monitor on mine, configuration, and this will show you the different monitors that we have configured. You can see the target IP address, size of the request. Essentially, all of these things that you see in this list are tweakable. So I can say, I wanted to keep the statistics more than 2 hours, and et cetera, et cetera. I already showed you the statistics. And you can do a debug. You can actually watch it send the probes, and it'll report it to the screen. So that's SLA troubleshooting. How about SPAN? Well, we've got to have the source and destination session numbers matching on the local switch, meaning when you configure, that's really what ties the whole thing together. When you configure a monitor session, that number right there defines the session. So I'm going to say session 9 source such and such, session 9 destination such and such, and that little combo, that pair, creates a monitoring session. So that must match on the local switch. It doesn't necessarily have to match on the remote switch. So for instance, if I'm doing RSPAN, I can use session 1 on switch A, and session 3 on switch B, and session 5 on switch C. Be confusing as all get out, but it would work, right? SPAN source or destination interface misconfigured. You can't, for instance, have a destination interface in an ether channel. You can't have, there's certain requirements around what a source and destination port can be. Actually, you can almost have anything be a source, range of ports. You can even have a source port be in multiple SPAN sessions. So I could be monitoring it in different ways and through different sessions. But if you don't meet those criteria, by the way, just go to Google and say, what are the requirements of my SPAN ports? And you'll, they have to meet those requirements or else they won't work. RSPAN VLAN not identified or added to trunk. So you saw when I created that VLAN 50, I actually had to go underneath the VLAN and type in remote SPAN. And that identifies that VLAN as an RSPAN VLAN. You have to do that on every switch along the way, and of course add it to the trunk, otherwise it's not going to flow all the way through. Final piece of advice on that one is don't forget to turn it off as well. Remember, when you're using RSPAN, you could be flooding your whole network because you forgot this monitoring session on a major server running all the time. So make sure you turn that off once you're done monitoring. Those are fun. And you've now seen how to troubleshoot IPSLA, SPAN, and RSPAN. I hope this has been informative for you, and I'd like to thank you for viewing.